All right, here we are. Hi, we're streaming. We're live. Okay, that's good. What an intro. I'm Agent Ultra. I'm here to work on some code. I work in Haskell on this stream. I do little projects, side projects, little fun little projects, learning things, and just kind of chatting about stuff or whatever. Anyway, this for the last little while we've been working on learning about wave function collapse. We have an implementation of the algorithm. We're working on a visualizer now, so like so that we can see an example of the algorithm at work visually. So that visualizer is a little program that's going to take a little input image and it's going to generate an output texture that we're trying to work on. Right now, though, we're kind of in the guts of it at a fairly low level. So we made this decision early on to like create our own little input format for the algorithm to use, so that we didn't have to like program the library to use like to understand all the different image formats out there, I guess. And the idea was that the user of the library would write a translation layer that would load their pixel data into our input data structure and then send it off to the algorithm, and then the algorithm would spit the same thing back out, and then they could have a translation layer that go back to their pixel format. So we're working on that translation layer right now, and just kind of getting a feel for the issues around that and what we're demanding of our users. Turns out pixel formats are a thing. They're not super complicated, but writing that to and back again part is a bit tricky there. I think last week we kind of found, hopefully, the issue with it that we were missing there, which is what I'm going to be working on tonight. So once we can get that to and from layer working, those functions working, then we can hook it back up to the algorithm, and then hopefully we will see the results and the fruits of our labor on this stream of streams. This project that lasted, I think, a little bit longer than I was expecting. Actually, I thought maybe it would be a dozen streams at most, but yeah, here we are. 26, I think now. Granted, we're only doing this like maybe 2 hours at a time, and some of that is like ramping up on the code each week. So yeah, 20 hours on an algorithm. It's a bit. It's quite a bit. But we're learning. We're learning a fair bit, which is good. That's the purpose of this, right? So I expect, hopefully, if I've learned enough about this algorithm, that I could probably rewrite it again and do a better job next time. Have a better handle on things. That's how it goes with programming. Okay. So the thing is that we discovered last week, if you weren't following along, or you missed that one or whatever, is that the surface data. So when we load up a PNG, it packs the color data, the color channels, into like a single value, and the format for that value, inside that value, determines like where the red is, the blue is, the green is, the transparency, and so forth, right? And the library that loads our PNG is sdl.image, the SDL image library. And it loads this image. That image has a particular, that loading function actually returns a surface, an SDL surface. And that SDL surface has the pixel format associated with it. Okay. So it tells you, that pixel format tells you like where in that pixel data is the red value, the blue value, the green value, and so on. So on and so forth, right? That appears to be different than the pixel format that gets created when we generate a new surface and we're trying to go from our algorithm output back to a texture like that we could render using SDL. Right, so this create RGB surface function, we're giving it RGB A8888 here as our pixel format. And that seems to be different than from surface, what gets loaded. So when we go from surface, it's a different format than when we go to surface and try to render things back again. Which I think is probably a reasonable thing. They should be the same, at least. So let's try and make them the same. That means we probably need to keep track of the image data and something about the input image surface, its pixel format. So I need to look in the SDL API to find if we can get that out of surface we just loaded. SDL image. I could tell like the format, but that's not the... The format's not what we're looking for. Like, we know it's a PNG. We created the file. We verified all of that. It's not quit or version or anything. Like, okay, so it's probably in the SDL2 library, hopefully on Surface. Get surface color mod, alpha mod, blend mode. Lock, unlock, no, convert, no, get window, no. It might be just on the surface object itself. There's the pixel array. Okay, the surface format. Okay, it's a pointer to pixel format on the raw surface. So if we pull that out, hopefully we can hold a reference to that so that when we go to create surface, we can pass that back as an argument to create surface. Yeah. Okay, so then this would look like the return a tuple of the texture scient and the pixel format. And then to surface, we'll take that pixel format. I don't know if I can take it as a double though. SDL dot, there we go. Boom, boom, boom. Yeah, now type's gonna get annoyed with us, so that's fine. We're just gonna make it all work. So the types are happy with us again. Okay, so we get from surface, we get the surface object here. Dimensions. Surface pixels. I wonder if we don't have to go all the way to the raw, if the high-level surface object, or type, has it. That's a pointer to surface. Okay, it has a pointer to the raw anyway. We get the surface pixels from that. Oh, it's a function probably. Yeah. Clear surface pixel format? No, that's just the new type wrapper around the pointer. Just checking I'm not reinventing the wheel here. Doesn't look like it. Okay. We do have to get the raw. Then we have the surface pointer. The raw surface by peeking at that pointer. Now we have the raw surface, and we can then do the same thing to get the pixel format. I forget what the field is called. Right off the top, I have the memory of a fish. It's just surface format. Cool. And then we just have to return it. Except okay. We wanted an SDL the new type wrapper pixel format, not the raw pixel format. Do they export the constructor for the high level one so I can just wrap it? Okay, so what we have, we get the raw pixel format. It's not the same as the high level one. So maybe I could just update my type. But let's see. The purpose of this is to get create RGB surface with a pixel format. That takes a high level one, not the low level raw one. That also takes a high level one. can we get the high-level pixel format value there? SDL wrapper. It takes the pitch as an argument here, but you can't access the pitch directly from Surface because they don't wrap it. They don't expose that field at the struct. Oof. I feel like that's something that should be improved in this library. Maybe we should make a pull request on it and fix some of this stuff. Yeah, because I need a value of this. It doesn't look like there's any way, at least in this wrapper, to get surface pixel format. They just have the new type. That's it. As far as the document, as far as this shows so far, that's it. It just has the new type. I don't think it even uses it. I can't find a function that returns it. Or the search isn't does comprehend with it. Okay, that could also be. What would you call it though? Get surface pixel. No. Convert surface format or surface format. Okay, there we go. Okay. So surface format returns the pixel surface format, that thing. Okay, so we don't need to go that low level with this part, hopefully. Let's get rid of that. Let's get rid of that. That. Called surface format. Surface format of image. Okay, from there. Now that is a pointer to pixel format. So now I need to get from surface pixel format to pixel format. Does Google index this package maybe? Let's set it to... Okay. How do I limit this to a package? Do it like that? No. Yeah, I know the package. I just want to search within it, 'cause I don't know by type. I don't think Google's being very helpful here. Maybe because it's not indexing this package. It knows about SDL2, but could also be that this function just doesn't exist in here, and we are boned on that direction. Pixel format. Get window pixel format. Format name, no. Set pixel format palette, no. What's the point of this surface pixel format then? Because I need to convert to the high-level pixel format for create surface. Right? That's what I need. Come on. Can't give me a surface pixel format and then make it useless. Okay, well, like the only, like convert surface, okay, cool, a function that uses surface pixel formats. Not exactly sure how I'm supposed to create one, when all I can do is get one. And it's just a new type wrapper around a pointer to a raw pixel format, which is fine. But I can't create them. This is the type that's given to create surface with format. It doesn't take a surface format. Let's look at that function. Create RGB surface. Boom. Maybe we need to drop to the lower level version of this. However, the high level version takes not a surface pixel format, just a pixel format. Let's look at the source of this. Maybe it's doing the conversion. and calling raw, the raw version. Yeah. So, if we get a surface format, and that gives us the raw pointer to the raw pixel format, maybe we can pull out the same data here from the raw one as this one, so that we can call the raw create RGB surface and given the pixel format that we got. Workarounds. Unless there's a way for me to construct a pixel format from a raw one properly. Keep that in a tab. Palettes and pixel formats. Masks to pixel format. A BPP value and RGBA masks to an enumerated pixel format. Okay. Bytes per pixel and RGBA masks. Good gosh. All right. Do we have that in raw then? Pixel format. We have the BPP value. We have the masks. Okay. That means we can, I think that means we can write a function that converts this, does this conversion for us to that. Doohickey. Okay. Maybe let me put it in here somewhere. From raw pixel format. Okay. It's going to be SDL. We'll call it SDL raw .pixel format. Do an SDL .pixel format. I don't think I have SDL raw in scope. Oh, I do have raw in scope. That should be it. There we go. I don't have SDL.pixel format. That comes from qualified SDL dot video dot renderer. Oh, what's this one? Yeah, sorry. I'm getting distracted by that type error. I'll put a hole there for a moment. Okay, so we're still going to do pixel format there. Okay. Yep, good. And here. Yeah, so toSurface is going to need an argument. It's going to be pixel format. You have to pass in here. Okay, from raw pixel format, let's go. Okay, so from raw format, we need masks to pixel format. Has to be in monad, some monad. Monad IO? Yeah, that should be compatible. We'll just say monad M. If it's not, I'll figure it out. Just have to import a package. Okay. Max to pixel format. All right. Raw format. Dot. I can't really use dot here, so I'm not importing those correctly. So raw dot something on raw format and something else. Roller bindings are okay, we're gonna need monad IO to import that, that's fine. Raw format. Pixel format, bytes per pixel. Returns a word 8, huh? Yeah. Okay, that's super annoying too. Word up. Word 8 is just an 8-bit unsigned integer. Not exactly a cint, although it will fit into one. So maybe from integral will work on that. And hopefully C won't get too mad at us. Yeah, we're gonna need monad. Add IO. Which we don't have in our package. Monad IO, where did you come from again? Control monad.io.class. Which is the base. Okay, that's better. Kaboosh. Okay, so then we just need the V4, word 32. Four values. Then that function wants them in RGBA order, I guess. We're just going to pull this over like this, and this over like this. Actually, look at the whole thing. That R G B and A like this. Okay, not so bad. Okay, so we can get the surface format. If we get the surface format, we get the pointer to the surface format. We could peek that to get the raw surface format, pixel format, and then we can convert that to the high-level pixel format. Hooray! Oh, it's got to be in IO. Sorry. So I have to bind it. And we'll do it there. Okay, let's get the builder fired up. Let's see if this works. Hang on, we got a couple of warnings we should probably pay attention to here. Defined but not used. Pixel format. Okay, we got to use the pixel format in order for this to actually work. The first part of it compiles. And we don't actually use anything from that import, apparently. Okay. Okay, so to surface, pixel format here. Place that there. Pixel format. Okay, beautiful. Now, let's see what we get. Okay, cool. SDL call failed. Why? Oh, directly? Okay, interesting. Unknown pixel format. Well, that's not great. Progress. I like getting an exception rather than junk data. Okay, so we don't know... We're getting unknown pixel format when we convert this. So when we... Our conversion function, maybe? I am curious why the bytes per pixel in the raw format is a word 8, but this mask function wants cint. I wonder also if maybe this is in the SDL2 issue tracker. Just like the pitch thing that we encountered. Surface, pixel format. Nothing mentioning it. Just the pitch field. Hmm. Oh, just looking at this issue list. Ooh. Curious if SDL2 maybe not what we need this to be updated a little bit more if you actually wanted to do Haskell game development, like, and really take it to the pro level. Although there is a game on Steam that is built in Haskell. I wonder what they did, what they use. Just curious. Side quest at the moment. Distraction for a second. Defect process. Incoherent software. This one's made in Haskell. On the Steam store, you can go buy it now. It runs on Linux, Windows, and Mac. Built with Stack. Smart. Case. It is using SDL2. Image and TTF. Interesting. Very cool. Although, looks like it's using a different audio solution than the SDL2 libraries, I guess. I was just noticing in the issue tracker there that there were some issues around, like, video and music. How does that... Seems a little bit busted at the moment. But there's ways to work around it, I suppose. One thing I'm curious about is if they have any pixel format conversion routines in here. Search it. Yeah. Surface, pixel, format. Nothing. Guess they don't. Good for them. I wonder if we want the pixel format and not the bytes, this bytes per pixel for the argument 2. Masks to pixel format. Still the conversion to CN. No, still unknown pixel format. Yeah, we still don't know. We still can't figure it out from just loading the image. Well, by the time we load the image and then we pass that, yeah, whatever we're loading the image with, it's not parsing the pixel format from our PNG file. Maybe it is time to try a different file format for our input image. Maybe BMP or something simpler will work. Or be easier to detect. I don't know. Can't hurt. Export this to a Sprite01, but we'll change it to just good old BMP. If you can do that. Windows BMP image. Okay, let's see if that works. Still can't figure out the format. That could still be because we should be using VPP. No. Yeah, so that mask function is not what we want. Good gosh, good golly. SDL2 library, man. I don't know what to say. We can't do low. It is very difficult to do low-level pixel conversion from different formats here. And mainly, it seems, because we're lacking ways to convert between types. That should be there. Well, actually, there's probably one more thing we can do here. That's right. When it does pixel format to masks PF here. Yeah, RGBA. Yeah, we got it in the right order for the V4 row as well. And BPP. Cint. Yeah. This isn't. Yeah. This isn't quite right. Pixel format conversion. Yeah. I don't like that we can get to a raw, but we can't create a surface with a raw pixel format unless we go down to here. Which we might have to do. That's going to be our next upward attack on this. Yeah, create RGB surface. This is very, very poorly worded. You have like no idea what any of the V1, V2, V3, V4, V5, V6, V7, V8. Great. Cool. What is any of this? So let's look at the C library. Flags. A width, a height. A depth. R mask, G mask, B mask, A mask. Depth is the depth of the surface in bits. If depth is 4 or 8 bits, an empty palette is allocated for the surface. If depth is greater than 8, the pixel format is set using the RGBA mask parameters. Okay, so depth, I think, is what it's trying to set with BPP on the Haskell side of things. And where were we? through. Pop over here. All right, 0, blend mode, width, height, BPP. Depth after the width height. So I think the Haskell side is calling BPP the depth. All right, so if depth is 4 or 8 bits, empty pal is allocated for the surface. If depth is greater than 8, the pixel format is set using the RGBA mask parameters. The RGBA mask parameters are the bit masks used to extract color from a pixel. All right. So one value, and you use bit masks to extract the colors for the different channels, and they can be packed in there in different format, depending on the format. All well and good. For instance, yes. Okay, the first byte's out of red. First byte, FF, that's the mask. Red data is stored in the most significant byte. Using zeros for the RGB mask sets the default value based on the depth. Okay, so if we set this to hardcode this to 32 is my guess. I'm just guessing that's a good value for it. Let's just try 32. And that this raw format is all good, and the pixel formats are there, and everything. Okay, 32 is a good guess. 32 is an alright guess. Okay. PNG? Does it work for PNG as well? Does. Okay. Yeah, so yeah, we're just missing some data that we need access to here in order to do these conversions properly using the code. So that's unfortunate. That can be fixed, but it's not going to be fixed here and now. Okay, so the other thing that's wrong with this is that obviously maybe we're missing some data here, I think, perhaps, possibly. Okay, so that's decent. Decent-ish. Yeah, let's get rid of that. Clean this up and create a commit. A work in progress commit at least. So we know I have to get this pixel format through. We figured out a way to do that. These functions are kind of like the dual of each other. I wonder, with some shared, like, kind of dependent data between them, this pixel format. And so in order to use it correctly, you have to make sure you pass the same pixel format return from surface to surface. I don't know if we want to wrap that up in an interface for users as like a helper for them, so that they can do this properly and not go through all this rigmarole when writing their own wrapper layer for working with our thing. But yeah, what a journey. Okay, so that's looking good. Let's just take a look at the diff. Add one audio class. As we go, we get the pixel format back from surface, and then we pass that pixel format to surface. That's some unnecessary white space change. that. Okay, so our implementation of from surface now returns that pixel format. Good, good, good. Good, good. All right. I'm happy. You're happy. Ah, of course. I messed up something with my Emacs because my BM is a whole thing. Ah. Okay. And then we can tackle the next bit. This helper function to convert helper function to convert from raw pixel format to high level pixel format. Not super great. We hard code the depth parameter. Because it doesn't appear to be exposed on the raw pixel format record. Okay. Well, I should probably revert that just to put a little work in progress. Okay. Next part. Okay. The next part is that texture, or the surface that we create, looks like it has a row of pixels missing. Which means our index is up. I thought we fixed that, perhaps, but maybe I didn't merge that properly, or I forgot, or something. Or I'm just misremembering things. I have to go back and watch my own VODs. No. So, let me just test this theory. Build that. Yeah, it's just missing a column here. It's got the rest of it. Missing a column. Which means offsets, stuff like that. Okay, so from surface. raw pixel format. Raw pixel format, and then the pixel format stuff we just added. Surface pixels. Okay, get pixel from 0 to image width -1. Y and X. Okay. Get pixel down here. The hard-coded BP is depth as 32. I'm wondering if the same thing will work here. I mean, the front integral on 32 is going to be unnecessary there, but probably there as well. Ooh, nope, that was totally wrong. That was right in this case. Oh, is it C int to CU int? Those are differently, well, they're different ranges, but I don't know if they're different sizes. Going on a hunch here, maybe it's the CU int, maybe it's differently sized. Why would that make sense though? If the offset, like it's just turning it black, so it could be that the data it's picking up for that column is missing. And we're getting 0 there, or like junk data. Whereas if it was properly sized and getting the right run length here in this calculation, then and the byte offset, then maybe that would explain why we're getting black in that column and not the pixels that we expect. But everything else seems good, so we're not going out of bounds, otherwise we would get an out of bounds access error from this byte offset off this pointer. So yeah, CU int, CU int there. I didn't over here. Because texture has to be updated to CU int. There's a small part in here. Yeah, this pointer here. Casting. That's set pixel. Yes, you went there. And here, where are we? Oh, the value we want to set, right? Pointer, X, Y, and then the pixel data needs to be CU int as well. Yeah, that wasn't it, but we're still okay. It didn't affect anything so far. It's our byte offset calculations off a little tiny bit. Take that offset bytes from there. That's probably not going to work. I'm just guessing. No. That's right. That's right. Getting it in the right order. What do you mean? You were banned and reported. All right. So we're really close here. The pitch. We casted a few ints, and we peek at the byte offset in the array based on our X and Y. And the CUIN is going to tell us how much data to read off, which, like I suspected, is the same size as the CUIN, so that didn't really affect anything. Yeah, it's got to be our base pointer. Oh, Peter Cardoso 21 followed me. What's up, dude? Thanks for the follow. Why don't you say something in chat if you're up for it? Thanks for the follow. Okay. Well, well, it could also be that, like, we're getting the data. I'm great, P. Cardoso 21. Hope you are well, too, and if you're not, or you're struggling, that you will be soon. It's a bit chilly here, though, gotta say. Pretty cold. But doing well. Staying toasty. Okay, the other thing it could be is, like, we're setting the pixels wrong. Like... that could be a thing. Could be on that side. Okay, set pixel. Same formula for calculating where in the pixel, from the pixel pointer, the byte offset. We get it. Although we're multiplying pitch here instead of BPP. Call it pitch and set. Get. Oh yeah, it's pitch and BPP as well. I'm wondering if maybe that's the issue. Maybe it should be pitch across the board here. And BPP is only used in calculating pitch. Again, kind of guessing, shotgun, hoping that that will be the thing. Sorry, BPP needs to be up here. Brazilian, welcome. I wish I knew Portuguese better. I don't think I do know any, which is bad. I actually work with some folks from there. At least I should know maybe like hello. How do you say hello? Maybe I do know it, I just don't remember. And as soon as you say it, I'll remember. I'll be like, oh yeah. Pitch. Pitch. Yeah. BPP. Let's do pitch. Oi. Oi, yeah. Oi. Cool. Thank you. It's awesome. Oi, Picaroso 21. Yeah, I'm from some much northern latitudes, and it is bloody frigid at the moment. It's not the cold enough where like stuff on the inside starts freezing anyway, even if you have insulation, but getting close. Oh yeah. Oh, you're interviewing for a programming job? By any chance? Haskell programming? Yeah. Okay, so that worked. That compiled. Let's go. Not the pitch. Oh wait, I totally meant that, didn't I? No, I did mess that up. That should just be pitch here. And X times pitch here. Java programming. Oh, very nice. Very nice. Well, best of luck. Okay, so we don't want to offset into the pixel pointer by multiplying the pitch on the X. Okay. If we think this through a little bit, no, thank you, thank you. I think we're getting pretty close, and I've learned quite a bit about some low-level pixel format conversions and surface format conversions in SDL and stuff like that, and the Haskell bindings to them. Just kind of neat. All right, so image data in memory on in an SDL surface. Okay. It's in row order from the top left corner, one row of your output image of your texture or surface, and then the next row and the next row, the next row. All right. stored contiguously from a pointer. So I'm gonna highlight the row parts in yellow here. Forgive my bad drawing here. Okay, cool. Probably should make it a little bit more evident that these are two separate rows. You might not be able to see that. But like, contiguous though. Contiguous? Contiguous. That means like they come one after the other, continually, one after the other. And so when we're trying to calculate which given pixel byte offset we want on this pixel, we need to know the number of bytes per pixel in the pixel data. So like how big is an individual pixel? All right. The pitch is calculated from the surface width times the bytes per pixel. So that's to get our row width in bytes. All right. So if we have an output image that's 6 pixels wide, right? Then we need, in the size of that in bytes is going to be 6 pixels times 8 or 32, whatever that is. Right? So when we, in this part of the formula down here, when we multiply y by the pitch, we're calculating how far from this base the base pointer, and we're skipping over so many rows by multiplying it by the pitch. All right, so if we go 0, we should get this first row here. If y is 0, we should get this first row here. Okay, so in the current problem we have right now is that that one column on the very, very far left is all black, and it shouldn't be. So when we get 0, 0, we're not getting 0, 0, we're getting something else. The byte offset is something else. Which actually might come in handy if we use debug.trace. But let's see if we can figure it out from the formula here if we got something wrong. So next thing, we need to know how far into that row we need to go in order to get the x component or the column component of that. So which of these pixels we need to get. So again, it's going to be from some byte offset, we need to calculate some number of bytes into some additional number of bytes into that row. So I think this makes sense. Well, this doesn't make sense currently here because pitch refers to the length of one row. So it makes sense that our output isn't working here. I think we had it as just x times BPP before. So if x is 0 and bytes per pixel is 32, that should also be 0. So we should be getting 0 bytes for the row, 0 bytes into that row. So we should be getting the very first byte when we go peak offset, peak byte offset here. And I think in our input image, it is actually black. So things might be getting a little confused here when we start increasing x and y, perhaps, with these multiplications, if they're not correct. They're almost correct, but not quite right. Hopefully that makes sense, P. Cardoso 21. So I'm going to change this back to BPP here, and in set pixel. As we do to one, we must do to the other. Okay. which is probably a good idea to make that a function. However, let's look at output again. So there should be some green pixels here-ish that are just coming up black. I think this one up in the top left should be black, but I think there should be some green ones here. Yeah. I'm kind of like drawing a blank at the moment now. We need to... let's try adding some debugging here. And just print out what we're getting. More qualified, debug.trace. As debug. Let's do a little printf debugging here. And I want to make sure that go here. And what do I want to make sure that... what do I see? I want to see the... I mean, the X and Y's we know. Our width. It should be 0 up to something. So if it was a width issue, like we're going too far to the end, I would expect it either to be like an array bounds issue. We were reading data out of bounds, which I don't think we're quite doing. Because we're not seg faulting on anything. Ah, Picardoso. You know, you could. You could. It doesn't take I don't have a PhD. You know, I didn't study for years before I, in a wizard's tower or something to get to this point. I just kept writing programs in it, no matter how difficult it was. It's just like picking up Java for the first time, just like picking up C++ for the first time. You know, you got to learn a whole bunch of new stuff that doesn't make a whole lot of sense, and it takes a while to sink in, but you can do it. You just got to be persistent. It's going to be frustrating at first. I swore a lot at the beginning, but you can get there. But I'm also a little flattered that you really wish you could. That makes me feel like I'm doing something right. So thank you. It's pretty fun too. Yeah. And Java has a lot going for it as well, so. But programming languages are programming languages. You'll learn lots of them over the course of a career. I've been doing this for 20 some odd years, and like I didn't start with Haskell. That's for sure. Right. So I want to know what my offsets are here. I want to know the element of offsets here. I'll print them out here, and I'll print them out in set pixel and see if we're getting the same ones. Let's bind them up here. Y byte offset. From the girl, we'll just copy and paste this here, and this part of the equation here to here. X byte offset. And we'll copy past the rest of the equation from here to here. Put that here. And then we can pop this bad boy here. And throw that here. Yeah. Yeah. So I basically started doing this streaming like a bunch of years ago now, I guess. A year or so. And I started it to show, because like a lot of people didn't believe me that you could write software, like regular, everyday, industrial grade, hairy-chested, bare-chested, muscly, yes, real-world gridiron software in Haskell. A lot of people are like, think it's still a very academic language, only usable by researchers. But you can't write real stuff in it. I just wanted to show people that, like, yes, I'm writing that kind of software in Haskell. It's not just for research. It's good for other things too. It's good for a lot of things. Like I'm doing the FFI in this actually, as I've been learning it. It's actually really good, I think. I think I might do more once we get this project done. The next one I'm doing is also a library for a database that needs like where that database exposes a client library but it's really written in C, and so you got to like bind it using the foreign function interface in Haskell, and figuring out how to do that and learning quite a bit there. That I think would make for an interesting stream, perhaps, to work on that project after this one's done. Anyways, let's get this going here. I'm going to copy that in set pixel as well. And X byte offset here. And then I just need to know which one is which. Get pixel. And this one here. Set pixel. Okay, so I just want to see that those match up. They should, but... Ah, interesting. Well, actually, maybe not so interesting. We have all the get pixels. Oh, wait, yeah, so the get pixels, we want to make sure they match up to the thing. Okay, so get pixels. Let's see, let's say the last get pixel. We have more. Probably quite a few. Okay. There. That's the last get pixel call. 396 is the Y byte offset. And the X byte offset is 33. 396. We have 396 at 44, but then we have all these set pixels. They're just a little off. The first set pixel, 0, 0, and then we go to 44, 0, and then we go to 88, 0. Consistent. So our pitch length is 44, 88. Our first get pixel call. Okay. Yeah, so I think that might be it. We're getting 0, 0, 0, 3, 0, 6, 0, 9, 0, 12, 41, 24, 27, 33, and then we increase our Y offset. That looks right. So we're increasing by 3 each time. 3 bytes. So if our BPP is 3 bytes per pixel, that makes sense. We're increasing by 3 each time. And then when we increase Y, we should see a jump up to 36. 20 byte offset 0. Okay, whereas on the set pixel side of things, we don't necessarily have to go in the same order, perhaps. And we probably don't. Because if we look at the first call, it's at 0, 0, but the second one's at 44, 0. Right? And that's because we're going from the whatever array order we get out of pulling from our output texture data size. So we should see, though, a Y byte offset with set pixel at 36. So the next 36 we see I should see Y byte offset. Y byte offset 36. Set pixel. Okay. Y byte offset 36. $360s. And then we get to set pixel. And we're not seeing the corresponding Y byte offset there. So That's not correct. Okay. So it is an offset issue, which means when we get to loading the data into our texture object, and we get it back out, the what does this mean? What does this mean? We should be storing the texture data with the X and Y's, not the byte offsets themselves. What else is up with this set pixels data side of things? I can look at the column increases. Ores. Yeah, so the BPPs are still different. For set pixel. Interesting. I bet the BPP values are still different, even though we've set the pixel format and created the RGB surface using the pixel format. That created the right pixel data itself, but we're not affecting the BPP. Of the created surface. If I change BPP here to 3 and hard code it, compile it, I bet it'll work. Huh. Yeah. No, it didn't. It's not the way I thought. What's going on there? We have to order the set pixels. I still think the reason why I still think it's giving us a different BPP here than we get on the other side. Let me just go BPP here, and on get pixel. Go BP here. So this pixel format stuff is part of the solution, but not all of it. Yeah, set pixels offset is 4. Get pixels offset is BP is 3. So ooh, it burns me. Okay, so something about the data we're passing through around here, we're either not getting the right stuff from the wrappers on the Haskell side. Or I could have made a mistake here. That's definitely a possibility. Something about the pixel format stuff. I don't know why it's creating it at the wrong raw bytes per pixel when we create the surface. All right, when we call create RGB surface here, we pass in the pixel format. I would expect it, the surface that gets created, to have the same exact BPP for the pixel format. But it's not. Let's look at what the heck the code is doing in the library. Maybe it's not setting something right, or so this is the high level one. Yeah. So it calls the C code version RGB surface. So it does raw create RGB surface. It's getting the BPP from this pixel format to masks function. So let's look at that. All right, so this is taking in the high level pixel format that we tried to construct from the raw. All right, it's calling allocate on this. It's allocating on the stack. Pointer cin for BPP. RGB and A. What do we throw into BPP? Pass BPP to this raw pixel format enum to masks. Let's jump in there. Calls down the FFI, which is probably just a foreign call to the C code. What's kind of neat about the Haskell FFI, well, there's two now, and there has been for some time, FFI extensions, things. The CCall one and the CAPI one. CCall one calls foreign C code directly using the ABI calling conventions of the target platform. So, kind of neat. That means, like, on most Linux systems, for example, that's going to be the System 5 ABI, which means it's going to, like, Haskell's able to directly put these values on the stack in registers where it can, or passing in the pointers to these things, and then invoking the C call directly. So it understands the C calling convention, the native platform C calling convention directly. So it's FFI is pretty fast compared to other FFIs that I've used in more dynamic languages that have to do a lot more marshalling. This has some limitations, which is why the C API version was created, which does things a little bit differently. Anyways, bit of interesting information there. I don't know how useful it is. So this is calling right into the C code with these pointers to these things to this function here in C. So let's go look up that function in the SDL docs. So it's supposed to convert one of the enumerated pixel formats to a BPP value and the appropriate masks. Okay, so you pass in those pointers of format, and I guess it fills in the data in the pointers here, the that we've created. And that returns true on success or STL false on false if the conversion wasn't possible. Okay. So what does our Haskell code do? Calls this in lift.io. That supposedly might convert it to, this might return a bool. Yeah, IO bool. Okay. So supposedly that conversion can be done, no problem. Okay, so it returns a bool if it worked. And then I guess throw if will throw us a runtime exception. This isn't true. Then we wrap by dereferencing all the values in all of those pointers. Our wrap just returns our tuple and wraps up the RGBA values into a v4 and throws it back up here. So that's our return type. BPP as a cint. Okay. So this means in our code that when we call create RGB surface here, we need to figure out if the pixel format we're giving in here translates into why it's translating from a 3 when we get the raw pixel format from surface. But when we go to create the RGB surface, we're getting a different BPP value here for the pixel format. And I don't think that explains what this means. If we call pixel format masks because we called right here in create RGB surface. Pixel formats to masks. So the pixel format we're passing in the high level one. Pixel format enum to masks. Calls toNumber on PF. Okay, interesting. toNumber. That is interesting. So I wonder if we get the toNumber on the input image surface, so that pixel format. Look at the raw pixel format. We were passing the BPP in here, and we hard-coded it to 32. If I flip back on that, will it work? No, not right. The right name, or is it? Pixel format bytes per pixel. Sorry, it's just a integral call here. Okay. Yeah, then we get an unknown pixel format exception here. Interesting. Only when we go to set a pixel, I guess. We go to create RGB surface. Yeah. So if we try to use the BPP of the raw format, we don't actually get, from masks to pixel format, the pixel format used. It could be that that 2-number call is giving us the wrong number. The 2-number instance is bad, or hasn't been updated, or something is off about it. Right, like if we are fix BPP here manually on set pixel by just subtracting 1 from it. That is interesting. Okay. The set pixel, anyways, the set pixel 3 is right. The other thing that might be going on here is now the byte offsets and now that all the byte offsets are looking good here, it could be that we actually do have to set the bytes in a particular order, that we can't random access them. That could be that, maybe. I don't like having to hardcode that -1 in there, though. I don't know why that's... I don't like that that's doing that. So these aren't the same thing. They aren't returning the same thing that I would expect. Alright, I would expect to be able to go from a pixel format, like an SDL.pixel format, to a raw format, and from that same raw format back to the corresponding SDL.pixel format. But we have to do this monadically in I/O in order to call a C function lower level. At the lower level, this masks to pixel format thing. In order to do that, yeah, and then whatever we're passing in, we get this SDL pixel format we're getting back has a different BPP than the input raw pixel format that we created it from. That's concerning. And I guess it's probably because of that pixel format to masks. No, pixel format enum to masks. That's like, that's where we touch PF. We turn it into a BPP. Oh no, 2-number PPF. Yeah, that's where we pass in the pixel format. And then the C code fills in BPP. Alright, so this 2-number PF is telling the C code to fill in the BPP as 4 by the time we get to set pixel, which is why set pixel is at 4. We expect, and yet our input BPP, the input format was 3. Alright, so I think maybe this 2-number pixel format thing is not quite right. That's a possibility. However, when we hard code that fix, BPP, so that we get the BPP of 3 in set pixel that we want, we were getting not good output either. Jumbled up. I wonder if we order things there, but we call the set at the right offset with our value, that it's going to be better. Okay, so we need to be ordered by the Y column first. So we call array.soaks. We're getting the association list of the array, which is like a 2D array. That's an internal, kind of an internal detail of texture. We could, what do we want to sort up first. We want to sort on Y. We want all the zeros first, followed by the increasing columns, the X's. Could sort that here. That's going to sort lexicographically by default, I believe. Unless it wants me to have a function. We're going to need list on sort. List and scope. Import data.list. Quite build. Yeah, that's fine. I think I could just put y here. Building, running it. I think that's slightly different output. What we had before. That sort. I don't know, about the same. slightly different. No, yeah. Yellow, red, blue, pink, dark pink, blue. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. Alright, I have to wait for the build to finish. Yellow, red, dark pink, blue, yeah. Yeah, same. Okay, so the sort doesn't really matter. I don't know. I'm gonna trust my instincts on that one. I don't think the order that we fill in the bytes anyway matters a whole lot here. Okay, so that kills that idea. Hmm. Yeah. Since the BP is 4, we're getting like light offsets into these things at like say 44. We don't want. Well, bring data list in. Maybe just try sorting one more way first. We'll try list.sort on. I think that takes a function. Let's just pull this over a little bit so we can read it better. Yeah, we need a line here. Okay. So let's sort on this element here. We're gonna import data.function. On. I think compare is in data line. And we're gonna go first, second. Or is it second, not first? I'll find out in a moment. Yeah, second dot first. Or second dot second. Why is it not matching the type there? I have to put brackets on this. Hmm. I gotta be. Am I looking at the wrong function here? Google. Sort on. Is it a sort on or is it sort by that I'm thinking of? Yeah, I might be thinking of sort by. Sort on might be the wrong one. Okay. The argument there is interesting. Okay, my conception of on here is probably not working. Okay, and we don't know orderable. So it's an ambiguous type variable here because we don't know that we can order the thing. Compare is just a little bit too... Doesn't know what the first thing... Like what the type of first is, ultimately, I think. We could specify that with type applications, maybe? That might remove the ambiguity. I don't know why it's saying successful build. It really shouldn't be. The B0, the return type is ambiguous. Interesting. Okay, well, let's not be super fancy here. Let's just write it out the long way. Word, cu int, do ordering. We don't care about the x, we only care about the y, we don't care about the value. Oh, and two of these. Y1 and Y2. And we want to compare Y2. Okay. So, now that that's written that way, now, it's slightly different output, but not the difference I was hoping for. Okay. That did that that did it. I mean, of course it did. Amazing. Oh, I'm awesome. Okay, so I guess I don't quite understand why the BPP here isn't the issue. But the BPP offset for our target surface is different from our input, and that's fine. But it's the ordering in which we write the pixels into the array that matters. Once we sorted it into row order in the list from the association list of our array, then it was fine. Now, the efficiency in me is like, that sucks, but at least it works. It would be nice if we just didn't have to do a whole lot of copying and transformation here, but we do, for now, at least. Okay, I'm going to chalk that up to a win, though. Let's get rid of the debugging code. Get rid of that. Boo's not a good name. So, on is supposed... Let's try to get that before we go. I'm like way over time usually on this stream. Usually I only do about 2 hours here, but let's look at the type of on, shall we? It takes a function as its first argument. A B to B to a C. Okay. Second argument is an A to B. All right. We get one such A. Well, two A's, two things of the same type. All right, so it gives us back a function from A to C. So it applies the on function here to take those A's and turn them into B's so that it could pass them into this. So our A's in this case should be this tuple. Right? And our function from A to B should be something like word uint to word. Right? So if we did that, we want this word, the Y, to take the first, after taking the first element, take the second. Right, second after taking the first element. So first returns this tuple, and then second after that returns this part. Okay. So I would like to say compare on far. Why is this not this? Well, this type doesn't make sense for this anymore because now this type should be word ordering. No, that's not right. Okay, so clearly my thinking was wrong on that one. Oh, that's not working because I haven't imported that yet. Again, we're about to find out if I'm wrong. Data.function on. Okay, what is the type, or what should it? You think it should be when I sprite compare on var? Okay, you actually still think it's that. Okay, so it's just the type inference couldn't figure out, but I was right about the general idea. So if I replace this with, are you happy? Maybe. Yes. Okay, well, let's just come up with a better name for foo then. Sort by Y. Component. Okay. Cool. Let's create a commit. Let's rebase this. Squash that one, reword that one. When applied, this commit will fix surface to texture conversion. We added helper function convert from raw pixel to hello pixel format. That's still not great. And we also changed the ordering that we set pixels in. Pixels are set in view surface. Hebrew order. Okay, that's what I've got for this week. Let's push that up. So if you want to check out the code that we've been working on today, it's all up on GitHub. I'm Agent Ultra. It's been a pleasure. You can find it on GitHub at Agent Ultra Wave Function Collapse. That's I'm Agent Ultra on there. I'm Agent Ultra on the Fediverse as well, on the types.pl server. You can find me at Agent Ultra there. You got links on that profile to my website. You can just go to agentultra.com. That's me as well. It has links to everything as well, like including my YouTube channel where I back up my VODs for this stream. So if you want to catch up on those or check some other ones out, you can go there as well. If you like what you saw tonight and you want to see more, you want to be notified, even better, when I go stream, give us a follow here on Twitch. Greatly appreciate it. Or if you're watching on YouTube because you're in a different time zone or whatever, give us a like, a subscribe, and a thumbs up there as well. Leave a comment, all that kind of good stuff. I usually do these streams on Tuesday evenings about 10 after 8 in the Eastern time zone. So if you just want to write that down and show up around then, feel free to do that too. It's okay. It's all good. What else? The link above my head. Discord, or not Discord. It has a link to a Discord server at that link. There's a channel there on that Discord server for this stream, so if you want to talk about your projects or hang out, there's also a lot of cool streamers who are doing stuff in other languages, like, I don't know, Erlang and whatnot as well, too. So go check that out. And, yeah. May all your monads be free. May your types always check. And I hope to see you again next week. Happy hacking out there. And take it easy. Stay warm. Or if you're somewhere hot, stay frosty.